So we already graphed some of these so-called petals containing functions, and that's the analog of a graph of so-called lemniscate. Notice that the graph here could have possibly have more in it, but it doesn't, because r squared on the left side means it's positive, or maybe zero. In other words, we're only concerned with values of sign that are positive and not negative. And those be the ones that the negative ones will actually make these parts of graph to disappear. So let me try one of these type of graphs with r squared present and see this a little bit better in more details. And of course, the one they considered as example, you can also try to graph if you want. So looks like problems number 53, 54 are of that type. So I can take a look at 53 to graph. So this will deal with r squared, which is 9 times cosine of 2 theta. So what I have to right away say to myself that cosine of 2 theta must be only positive, right? So that's what's important to realize. And if I recall when exactly cosine is positive, then we're gonna be concerned with this half of a unit circle. So here, including, actually, it could be, so including the end points, cosine will be positive. So I can describe this such a way that theta, or actually here we have 2 thetas. So 2 theta is going to have to be in between of larger values pi over 2 plus period, which is 2 pi times k. And the lower value will be minus pi over 2, right? Plus 2 pi k. And from here, I need to to isolate my angle theta to divide everything by 2, and that will end up being multiplying by 1/2, right? So put 2 in denominator is analogous to multiplying by 1/2. So this everything will be with 2 in denominator, in other words, divided by 2, so that theta is found. And we can see now that this is in between negative pi over 4 plus pi k and positive pi over 4, again, plus pi k. So how can I see this on the, oops, I'm trying to make a picture of circle. That's definitely far away from being a circle. Oh, this nice thing erased a part of my solution. This is very nice. We need that for sure. Pi k over 2. So if I get a careful circle, it's a little bit better, closer to reality, then I have pi over 4s to deal with. And I continue with the opposite side because my period is pi, so that's half rotation. So our angles of concern will be here, as well as there, because if you rotate by pi, which is 180 degrees, then you get this part. So that's for angle theta. So theta goes from minus pi over 4 to plus pi over 4, just like in our inequality that we produced, but also 3 pi over 4 to 5 pi over 4. And that's where the graph is going to be. So not in the upper and lower quarters, but in the left and the right ones. So that's with cosine. If it was in a sine category, if it was the next exercise that deals with a sine, then it'd be above and below, because that'd be zeros, values for sine that we concern us. Well, anyways, we now need to get favorite minimum and maximum. Remember, it was always minimum, maximum, and a zero, but looks like minimum will be a zero value because you can't get anything smaller than zero, because again, that's values of something squared, and the square will be always positive. And the maximum, which is going to be a value of 9 times 1, right? Which is 9. In other words, cosine of 2 theta is equal to 0 at minimum, and cosine of 2 thetas is equal to 1 at maximum. It cannot be negative, so just positive. So anyways, when cosine is 0, well, looks like on a picture above we have these 2 points, because cosine is x-coordinate. See, it all boils down to solving little equations. That's what we already learned how to do. So we can describe this as a pi over 2 or minus pi over 2, right? So I can say pi over 2 plus pi times k plus period, right? Because if I rotate by another, get another color, by another pi, I will get here, and rotate again by pi, get there. So I take a half of everything, so put 2 in denominator. We get angles theta, where we have our largest values of radius, which is 9, and this happens at pi over 4 plus pi over 2k. So I can prepare this by taking pi over 4, that's the angle, and put 9 on it, so that'd be the largest value by my radius. And since it's pi over 2k, the period, so I got 4 values, right? So pi over 2 is here, and there, right? And those are the maximum possible values. We should definitely compare it with the allowed region, because some of these may not really work, but we will see later. Now for the minimum for values of 0, analogously, I can see that, oh, sorry, actually this is values of 0, so I wasn't careful. No, this is 0, is right? Cosine is 0, I got carried away. So these are zeros actually, because pi over 2 is cosine is 0. You know what happened to me. I guess I need to wake up. So next one is actually number 1, right? So this is going to be here. So this is r equal to 0. Just somehow switch these. So anyways, cosine of 2 thetas is 1, going to be only here, only that point, which is called 2 pi k. 2 thetas is equal to 2 pi k. Okay. So what about theta itself? Well, that's pi k. Pi times k. So that happens with maximum values. And those are going to be actually the ones on the distance of 9. So these are not the points that I put correctly, but I can just prepare the actual one with green for a change. So 9 will be here, 9 units, and on the other side will be there, like -9, right? So that's again for angle equal to pi times k with 0 angle or pi angle. And then I can connect these so that they fit right into my tangent lines here, as well as there. So it's like infinity symbol, right? This lemniscate. And notice there is nothing here on the top and there on the bottom. So once again, these points were when r was equal to 0, so pi over 4 angle means that we are returning to the radius equal to 0, which is we sit at the origin. And I want you to notice one thing that you will actually learn in Calculus 2 class, that it's always going to be touching. So when you graph, it's going to always touch this angle pi over 4 when you're going towards r equal to 0, distance 0, towards the so-called pole. Then your graph will touch that angle at which we have that so-called pole, and same with the others. So if you go to the other direction, again, negative pi over 4 is also going to be tangent, people say. But why, you're going to see explanation later when you learn derivatives. So another graph, and notice that key points for maximum and minimum always work, and also you need to just be careful, make sure that you solve these little equations correctly, because otherwise you can get all kinds of answer, and that's not what we want to get, right? So another graph, so-called lemniscate. This is very different. I know this is very different compared to what you have been learning in the other math classes. Well, it's a specific of this trigonometry class, and that's what I guess I spent the rest of the class time on. And we don't have much of class time left, so I can graph one more here just for practice. And I recommend that you also redo the same problems that I done here, as well as there are some examples that appear in the beginning of this section. As usual, there is a bunch of examples, and they also are good to take a look at. So let me try one more, like 45, another recommended exercise. So we can do this carefully. And the plan with minimum, maximum, and 0 always should be considered, because once you find those special points, then you can usually get a graph. If not, you need more points. So r is equal to that value, so I need to get when r is the largest. Again, depending on the resultant here. So you see that largest could be when we add 2 with that number 1. So that happens when your sign value is equal to 1, because sign is always varying in between negative and positive ones, and that means that you have possibility for the sign, which is 1 for the largest, right? And -1 for the smallest. In fact, you can right away also notice that minimum value will be 1 plus 2 times -1, right? And this be -1. We'll see what this means. R could be negative. So now I know that sine theta is 1. That's what I'm concerned with. And here sine theta is -1. Right? So I care about solving these two little equations. And to help me out, I always recall that on the unit circle, there are values for the sign, such as a +1 that appear here. So angle theta is pi over 2 plus pi n. Right? So here's just theta. So 2 pi k, sorry. So we don't worry about dividing anything by period. So that's pretty straightforward. So you just care about angle pi over 2. Because on contrary with the previous example, I don't have 2 theta that makes me to divide everything by 2 and makes my period change. But here it just stays the same. So analogously for the lower value, which is here, theta will be a negative pi over 2 and period 2 pi k, so I don't have to worry about it. So when r is equal to 0, well, you have your function equal to 0, so you need to set this equation equal to 0 and find solution for that. So I can 2 sine theta. Bring 1 over to the other side, right? Let me do it slowly. And then divide this by 2. Maybe I'll get rid of this picture. So it'd be minus 1/2, right? Which is equal to sine of theta. And I get 2 other special angles of concern equal. So what are the angles that I care about? Well, looks like I will worry about cases when sine is equal to negative 1/2. So there are 2 points on the unit circle to describe. And if it's a negative 1/2, I think angle is pi over 6, right? With a minus. So if you think of pi over 6, how many of them we have here? For the other value, we're going to have 3 and 3, 6, and 1, 7. So theta either 7 pi over 6, or if you wish, a little faster, is negative pi over 6, or you can actually see that's going to be 7 and 1, 2, 3 more, no, 4 more, 11 pi over 6. Whatever is convenient for you, because again, that's intermediate step that enables you to actually get this graphed. So let me graph. So my point is there's the same pattern, and you just have to solve a bunch of little trig equations when you're doing this. So I have to now make a picture of these points of concern. So here's a minimum value, here's a maximum value. So maybe I'll start with a maximum, pi over 2, and the maximum will be 3, so I can put like 3 units. So here will be first point in the graph. Pi over 2 is the angle, right? So that's my pole. So it's 90 degrees. So I just got that one. Now, what about the next one? Looks like negative pi over 2, and we have negative 1. So what does that mean? Well, if I have negative pi over 2, that's angle down below. But radius is negative 1, means I have to go the opposite direction. So the point will be here, right? Because r is negative 1. You see that? Negative 1. We'll see what this means. And then we also have special angles pi over 6. So that'd be here. And kind of symmetric down 7 pi over 6. And at those two, the radius is equal to 0. So that's where we touch our pole. Which means that if I start out here and have it as tangent and then continue, I will hit that point. And then I go down to it, and again, somehow I have to end up there. So it's again tangent. Now what? Well, now they're all negative, so they have to go like that to this point, but they're going the opposite sign, and then there's another opposite sign. So it's like a lima cone with a hole on the inside that I just produced in here. And of course, you can always solve more little equations and calculate these points. I just want to show you example here on the picture, like one, the lima cone with a hole. So this is the one that I produced. So these graphs are pretty unusual looking, but they try to classify this with the little table 7 here that is actually being continued from the top. And that's why I don't want to get into this table, because there are so many little things that come into play, but you technically don't use it. You just go with maximum, minimum, and zero, and that's about it. So my plan will be to give you final next week on Thursday. As usual, I will email it to you like we did with a midterm. So it's a week from today. So on Tuesday, next week before final, we're gonna review. We're gonna see what exactly gonna be the problems for the final. And there'll be 2 exercises. So I'm gonna send you one and then work out another one on Tuesday morning. So you will know what to concentrate on before final. So we're done with the material. This is the last section. I don't think I wanna go any further. So I think we got a very good coverage of material. I talked to another instructors about this and they covered less. So we're in a good shape. So what else? Let me again stress the fact about the homework that you should email to me. And now, since you know what homework is, then you can email it to me even tonight. So I'm gonna again list those sections because people keep emailing me asking, what are the sections? Well, we just look at the recording of lecture and it's there, because I can't remember this on the top of my head. I have various classes, and to remember what exactly the sections are, is you have to not remember anything by that. So anyways, but it's not hard to open the contents and list it again. And for those students that don't know what sections are, you should look at the recordings of the lectures. That's why I email you those recordings. So 8.1 through 8.4 was chapter 8, and 2 sections in chapter 9. It's 9.1 and 9.2. And you can easily find what homework is by just looking at the YouTube recordings of lectures. I'm gonna over weekend post all of these remaining recordings on it, so you're gonna have a good place where they be all gathered in the same place. But you can always just check the last lecture, like today's lecture that I will be emailing to everyone in a few hours as usual. So that's our plan till the end of semester. And after the final that will be administered on Thursday, I will wait for you to email me everything, homework, the final, and on Monday next week, actually, it's not going to be next week after next, I will post your course grades on Canvas. So I will update it from what it is right now. And I hope it'll go up because I know that you're already very familiar with what's for the midterm, and same will be a requirement for final. Basically, just show your work and email it to me. And we're going to discuss this on Tuesday next week. So in the meantime, please put all your homework together and email it to me, right? So these sections, you can just do a couple of problems from each lecture that could be same exercises. So I'm sure it's doable. So make sure that you don't forget that. So I would recommend that you start today. Don't wait till too late, because by Thursday next week, you should be able to graph these polar relations that I just graphed. And that'd be something very similar to what I just did, one of those analogous. So we're gonna graph more on Tuesday. And that's what was the plan of my today's meeting. So I'm gonna stop this recording.